Hi everyone, my name is Feng, a PhD candidate from Delft University of Technology, the Netherlands. Today, I will talk about my research that investigates the usage of desktop VR and HMD VR to study pedestrian route choice behavior. Pedestrians perform route and exit choice behavior in buildings on a daily basis. Performing route and exit choice in large-scale and multi-level buildings, such as train stations, hospitals, can be difficult because of the complexity of the three-dimensional environment. VR provides the possibility to study pedestrian route and exit choice behavior in complex buildings. Different VR technologies have been used to study pedestrian route and exit choice, such as the head-mounted display, HMD, and desktop VR. Different VR technologies have different characteristics and may cause people to interact and perceive the virtual environment differently. However, only a few studies have directly compared the influence of VR on pedestrian behavior, and the experimental environment were relatively simple. Consequently, there is a strong need to compare VR technologies regarding their impact on pedestrian behavior and user experience. So that's the objective of the current study. We want to investigate the pedestrian behavioral difference and the user experience difference between HMD and desktop VR. This comparison will allow us to identify best practice regarding the usage of VR technologies for pedestrian behavior research. The current study builds on a developed VR research tool that was specifically designed to collect pedestrian route and exit choice behavior data in a complex virtual building. This VR research tool allows free navigation throughout the building, and it can automatically record movement and vision fields of participants. Applying this VR tool, we conducted VR experiments with a total sample of 71 participants. 36 participants took part in the HMD group and 35 took part in the desktop group. Each participant needs to perform 4 different wayfinding tasks, which including 3 normal wayfinding tasks and the final evacuation task. 2 types of data were collected. Pedestrian movement trajectory data were collected through the VR tool. Using this data, we can derive information such as route choice and task performance. Meanwhile, questionnaire was used to collect user experience data, including face validity, simulation sickness, usability, and the feeling of presence. Comparing the results from HMD and desktop group, we found that significant difference of pedestrian route choice behavior only exists during task 3. Regarding task performance, there are significant differences between 2 groups during all tasks, but we didn't find any significant difference of user experience between 2 groups. From results, we found that pedestrians from the HMD group had worse task performance. For instance, they spent significantly longer time. It might be because the HMD device is more difficult to operate, but more natural to look around and observe the virtual environment. And we found that when the destination was not clear-cut, namely during task 3, participants from the HMD group used more decision points, and the choice of staircase are significantly different. These findings imply that one could adopt more simple VR technologies for studies investigate simple wayfinding tasks. However, in case with the experience of the environment and certain behavior are important impacts on pedestrian behavior, one is advised to consider carefully the difference in pedestrian behavior between 2 VR technologies. Which of these 2 technologies is preferred for the more complex wayfinding is difficult to say based on the current study, as there are no validation studies compare pedestrian behavior in real life and in VR. So for the future study, in order to clarify which of the technologies should be preferred, direct comparison of pedestrian behavior in real and virtual building is needed. Thank you so much for your attention.